Everyone, welcome to the Edge. We are still continuing with trigonometry. So now, we are asked to solve for an angle given the following equation. Sine angle is equal to minus 0.47 degrees. We're asked to solve for an angle. If they want us to solve for an angle, essentially they want us to give the general solution, right? Something you've done in grade 11 already, but let's go ahead and do it this time around again. So with the general solution, we know that we have to get a single trig ratio on one side first, and then on the other side it's going to be the angle of the number that we want to solve over here. In this case, we want the angle of this. So firstly, the method that I recommend, the method that I recommend is first get the reference angle, right? Second, use cost diagram to get your general solutions. Okay, going to further elaborate that with this example. Let me just put it there. Cool. So if we pull out our calculator, in order to get the reference angle, let me minimize first. In order to get the reference angle, when you're given a negative number, for the reference angle, ignore the sign, ignore that negative. We just want to work with that number only. Just ignore the negative. So in this instance, it's going to be shift sine 0.47. And so the reference angle is 28.03, right? 28.03 degrees. That's our reference angle. So we completed the first step. Second step is use cost diagram to get your general solutions. Okay. So now that we got our reference angle, let us go ahead and draw the cost diagram or the Cartesian plane, right? I just like to draw these angles, to make things easy to understand. Now, one thing we have to ask ourselves is, we are working with sine, right? So this cost, we're working with sine angle. The given number is negative. In which quadrant is sine negative? We know that, it's positive. Yeah, it's positive. But, it's going to be negative and negative. In the all quadrant, everything is positive, meaning that cos, sine, and tan are positive. In the sine quadrant, only sine is positive because it's its quadrant. In the tan quadrant, sine is going to be negative. So, okay, since here we're given negative 0.47, it's going to be in this quadrant. In the cos quadrant, sine is going to be negative as well because it only belongs to cos. So, we have these two quadrants that we're going to work with to get our general solutions. Cool. So we know that since we're working with the T and the C quadrant, the tan and the cos quadrant, we know that their forms is 180 degrees plus reference angle and 360 degrees minus reference angle. So for the general solutions, you're going to use these two expressions to get the general solution. So for the first one, first solution, let's write it like that. It's going to be angle is equal. Let's start with the 10. With the 10 form, it's going to be 180 degrees plus the reference angle that we just solved here. It's 28.03 degrees plus k dot 360 degrees, right? So always for general solution, you must never forget to include this. Let me recap on what it means. Okay, firstly, let me just What is 180 plus 28.03? It's 208.03 degrees plus k dot 360 degrees. And don't forget to say k is elementary to z. This z is integers, right? So what does this mean? Well, why do we include the k dot 360 degrees? By the way, we only include k dot 360 degrees for sine and cos only, not for tan, right? Okay, cool. So here we got 208.03 degrees, right? So it's going to be somewhere here between 180 and 270 degrees. So if I can just erase these, and then do this 208.03 degrees, right? So this k dot 360 degrees means that if we add 360 degrees, if we revolve 360 degrees, we're gonna get back to this same point. We're going to get back to this line. And this k means that it doesn't matter how many times you revolve, but you always have to revolve in 360 degrees. You can revolve 10 times in 360 degrees. You can revolve 360 degrees 1, 2, 3, 4, 5, 6, 7, 8, 10 times, right? And you're still going to get back to this same point. That's what it means. And it has to be integers. It cannot be decimal numbers. It has to be integers. So from 1, 2, 3, 4, 5, 6, 7, counting like that, or negative 1, 2, 3, 4, 5, 6, 7. So negative that you can also go back clockwise or anti-clockwise, right? But it has to be integers. If it's going to be decimal, you're not going to get to this exact point when you revolve, right? So it has to be in integers, not decimals. It just has to be integers. That's what it means. Cool. So we got the first solution. Second solution, we use this 360 degrees minus. So angle is going to be 360 degrees minus the reference angle that we solved, which is 28.03 plus k dot 360 degrees, which is going to be 360 degrees minus 28.03, 331.97 degrees plus k dot 360 degrees. You have to state this, but if you stated it once, it's fine. If you say this once, you don't have to say it again. I just said it again because, yeah. So, we know that this was for the red angle. Let's use a different color for this angle. So, 331 is somewhere over here. So, perhaps, let me draw it with a black pen first. So, perhaps it's going to be there. And if we're going to revolve, you will see that it's like, it's 331.97 degrees, right? So yes, as you can see, both 208 degrees and 331.97 degrees are in the quadrants where sine is going to be negative. And earlier on this video, as we established, the cos quadrant and the tan quadrant are where sine is going to be negative. So this is the form that I would highly suggest when you're going to get a general solution. Firstly, get your reference angle. Secondly, go to your cos diagram, see, okay, where is the given trig ratio going to be, whatever is it, if it's going to be negative or positive. See where it's going to be negative or where it's going to be positive, depending on whether you're going to be given negative or positive. If here it was positive 0.47, we would know that, okay, it was going to be in this quadrant, in the all quadrant and the sine quadrant. That's where sine would be positive, right? And I hope that I made sense in this video, and let us look at more examples like this in the next couple of videos. Thank you.